Okay, thank you for having the chance to present here. And actually, we all know domain-specific languages. There are a lot of blessings of them, including easier communication with domain experts and maybe in some cases faster development. But there are also some problems. And what are the problems when you take a look at the development effort in bigger software projects and you use basically normal programming language? Maybe the curve looks like this, right? The project gets better, the complexity increases. Now, if you use DSL, you have some upfront effort to implement the DSL, but maybe it pays off. I think this is one of the nice things of the DSLs, that with the size of the project, you get here lower effort. Now, at some point, however, the DSL expressivity has some becomes too narrow, and you need to extend it, or in worst case, do some wicked workarounds. So now at this point, you're getting into trouble. Your effort for the DSL project increases, and maybe after another 2 years, you get again some gains from this. So, okay, obviously we have problems. That's good. So we can, yeah, we can address them. Okay, so what would be an ideal situation in DSL engineering? As usual, we first had a solution, and then we thought what would be a good set of problems to justify it. And here are a good set of problems. No, of course, I'm joking. So what would a solution postulate? So first, of course, low initial price for implementing a DSL. A second postulate would be no extra overhead for tasks outside DSL. So if you hit this expressibility limit, and of course goes with this integration with existing code base, and finally support for common IDEs. Everybody wants to program in their own Emacs or other weird kind of editor. So the overall tool architecture which we designed is the following. We are using basically a language server protocol, which is something which was introduced with Visual Studio Code by Microsoft, which allows you to completely separate the GUI from kind of back services. And we are essentially wrapping our solution in such a LSL, language server protocol server. And here we have two parts. The one part, which is the core part, maybe most interesting for language developers here, which is called NLDSL lib library. And then we have a basically kind of plugin which implements the interfaces and communication to this language server protocol. Okay, so language server protocol, basically that's a nice thing which finds now which is implemented in most common IDEs, not only Visual Studio Code, but things from JetBrains like PyCharm or Vim. I think there are also plugins for this. So you can actually use your own IDE as needed. Now let's try. So we kind of solve the last of these 4 challenges. But let's take a look at the other one, at the integration. I think this is one of the major practical problems and maybe, let's say, roadblocks when you use DSL, that at some point you need some extra code which cannot be used with the DSL. So typically when you are basically implementing a project using DSLs, you have essentially 2 separated programming environments, or even 2 separated languages. And when you mix them, maybe your generator is creating your target code in general programming language. But at this point when they are mixed, usually you cannot edit them. Yeah, so basically you need to go back, and here all this problem come up that basically, if the expressibility of the DSL is too low, you have to fall back to GPL or either some other stuff. So what we propose here is to generate the code on demand during editing. So instead of having this chain where you basically write a program and then at some point during the build phase it is merged, we essentially say during the editing, we expand the DSL into executable code. And so how does it look like? For example, here in Python, you have mixed DSL in comments. So basically, the Python compiler does not care about this. But when you hit the code completion button, you get, as one of the suggestions, your generated code. So you can include this immediately in one file. So, so what can you do with this? After you have edited your program, you can basically take this Python file. You don't have any dependencies on the tool or the DSL. You can immediately integrate this with the remainder of your projects, which kind of partially solve another challenge, integration with existing code base. Okay, now the most tricky part is, of course, lowering the effort of implementing DSLs. So there is no free lunch, so we have to give up something to do this. And our choice was to say, okay, we focus only on a particular family of DSLs, namely families where implement this kind of fluent API, where you basically chain methods, which is anyway kind of popular in data science languages or even other languages today. For example, think about Java 8 Stream API. This is all chaining of methods. Okay, so for this kind of DSLs, we created a framework which helps us to basically improve this. And we are essentially allow faster creation and updates of core DSL operations. I will explain in a moment how to do this. And second, what we provide is a kind of ad hoc DSL extension. So while you are editing in your code, in this code, you can say, I want to define here a DSL function. So you add in your, it can be very local. You can add a new DSL function, and it is immediately available. It's immediately available by the code completion and, of course, the expansion. So this is another way where you basically, okay. So, okay, maybe the Fluent API, I can skip this. We know this, and but by the way, especially in data science API like Pandas, Spark, etc., this is kind of popular now. Okay, let's take a look how we implement DSL operations. So this is the core. When you implement a new DSL, there is no way to avoid this. And one of the things which we have noticed is that it's sometimes difficult to synchronize different parts of code. Usually when you implement a DSL with a tool like Xtext or MPS, etc., you have different files, and when one of the syntax element changes, you need to change the syntax description, you need to change the code generator, etc. And here, in this case, we basically put everything together in one Python routine. So if you have a new new operator in your DSL, we define all these things together in just one single routine. What you see here is a complete implementation of operator group by, which we will see in a moment in a demo, where basically you generate Python code depending on the arguments. So that's all. The first part is normal Python documentation string. And in this part, you are specifying the Dsl grammar. So you say here, in our DSL, we would like to look like this. The keywords should be grouped by, then it should be parameter, which is a list of columns. Then comes another keyword, and then you choose aggregation operation. And this aggregation operation comes from this fixed set. And we say this is operation. Okay, I skip this part. So this all is parsed by our library and basically declaratively sets the syntax of the DSL. And here, this is the code. Essentially, because we have chosen this pipeline or Fluent API type of, most of the cases, we just need to parse the parameters, and append a string. And here you are essentially append just a string to the existing code, group by. That's the way how pandas implements this. And then basically you choose one of the parameters which user has specified. And then, okay, so there is one point where we are not local. We need to, another point, say we register this function called group by. It's the Python function as a part of our code generator. That's the complete thing for one new operator. And well, it helps a little bit to conquer the distribution of different elements when new DSLs are implemented. Okay, so the second element of trying to accelerate DSL implementation is are these instant DSL extensions. So within the code where the DSL is used, you can define essentially a new function or rule in the DSL. Here's an example. I want to introduce a new DSL element, divide two columns, and here are two parameters, column 1, column 2. It's another keyword, and the result should be named like this. And then I need to put here the chain of already known DSL elements. So append column, and this is also DSL, these are the parameters, and so on. And when you define this, you see we have a little bit different prefix here. Immediately later in your code, you can use this. The code recommender will suggest this to you, and it will be immediately expanded. And we can also show this in the demo. So when you, for example, in this particular case, you see here I'm using this div columns. I give two arguments, and here the name, how this should be named, and then the Python code is generated. Okay, so this is essentially a tool to defining new DSLs, pipeline-based DSLs, but of course you need some proof of concept. So we have all implemented some data science DSL, especially. We have been the most, let's say, frequently used commands or APIs in Pandas or Spark are this table manipulation, queries APIs. We have implemented this as a DSL, and we can actually have one DSL, but it can create code in Pandas or in Spark, and we can see this if time allows. You can even mix this in one file. Okay, so so in general you can specify different targets, but you of course need to implement them. But you can also have this additional sub-DSLs. For example, on top of this language, if your particular application domain, let's say, is student management, you can define your own DSL commands which specifically describe operations with students. Okay, so before I come to the demo, I wanted to tell something about availability. So there is an online tool, essentially on web browser integrated IDE, which you can access under this secret IP address. And but it's described in the tool demo in the tool proposal. And there are and for the NLDSL lib part, where allow you basically create new DSLs. Everything is public on GitLab, Docs, and also in PyPy package. So we have already some kind of prototype of the Visual Studio Code extension, but we want to basically make it a little bit more robust. So later it will be published. So let me give a short demo about the tool and see how this works. Okay, so basically, we are offline. That's not good. You mean this? No.
Royal 2019.
Okay.
Wi-Fi password.
Okay.
And all
but
capital letters.
I'm online actually. I should be online.
It glitches out after 24 hours.
I'm sorry?
Sometimes it glitches out if you signed in 24 hours ago.
Maybe that's the problem. Yes. But it was just working in.
Actually, the case doesn't matter. I'm sorry? Actually, the case doesn't matter. Oh, does it? Yeah.
Okay. Indeed, I need to.
Try to maybe disable and enable Wi-Fi again.
Yeah, I just did it. Okay, if it doesn't work, no problem. We have here another version in basically in Visual Studio Code. So I just tried to share the screen.
Right there.
Okay. So that's the nice thing about this language server protocol. You can use it in a web browser. You can use it in Visual Studio Code or any other kind of things. Okay, so I'm a little bit. So let's say this is just a normal Python file, and you see here we have comments. So these are the comments, and then basically the generated code. So let's try to regenerate this code. I'm just copying this string. And let's say at this point I want to complete, so this is my chain of operation. First I say I want to make some operations on this data frame called df, and I want to select columns, and then maybe I do something else. So I press the code completion button, and let's say we do count, and then we can see what code would be generated, and this is code which is generated. Basically that's the valid Python code. Now, this thing now generates pandas, but let's say after you have created and prototyped your data analysis script, you want to move to Spark, which is highly scalable. No problem. We do this now with Spark, and let's see what this code will, what this DSL will give us. Wrong button. Well, actually, it's the same. Maybe something else in this case.
Did you evaluate line 2?
Sorry?
I think you have to evaluate line 2 first. No?
Actually, if the cursor is in this line, it will select its DSL. Yeah. But I think it could be this. Okay. Anyway, so you can actually change in code the target, and it will generate different.
So is it like to reevaluate everything automatically under the hood? Because I think that was the question. That you change the value in text, but did you trigger actually the change in the environment that would pick up the different packet?
So each time a recommendation is made, you are actually scanning the file by the last directive for which target you want to do.
So
yeah.
Should kick in.
Yeah. Okay, something more complicated. You see that here we have something which basically would be maybe a little bit difficult to write by hand in your target language. But in a DSL, it's quite easy to be understood. So basically here, we can also ask our tool to generate this. Okay, it's a little bit hard to see. And basically, you can add this here. This is the valid code, and so on. Okay, so I think it's you can play this yourself. As usual, the demo does not work as I wanted, but that's the standard thing.
Nicely. Thank you so much.
Thanks a lot.